All right. Okay. Okay, so it's time. I'm going to start the live stream for today. I'm not sure if anybody's here, but if you're here, let me know if you could hear my voice. Right, hopefully it's mic is okay. Just gonna start the live stream for today. Right. So this is Junichiro Horikawa, and this is a Houdini tutorial live stream series. This is 134th episode, and the topic for today is to implement a dungeon generation algorithm called Basic BSP, which is rather a simple algorithm in Houdini. So this is mostly an implementation of simple logic, but it's going to I'm going to do it geometrically as much as possible together with using Bex functions. Right, so to check what this algorithm is for, this is pretty simple algorithm. You first prepare a simple grid, a square grid, rectangle grid, and split it into two by using horizontal or vertical line. Makes two areas, two regions, one called A, one called B. And after this, you're going to recursively split those regions again and again. And for each regions, you are going to map the address for its splitted regions by preserving the parent informations. So if in the second loop, when you divided the regions, you need to have a informations of its parents, in this case A, for the next one. So it's called A1, A2 for the A regions, A base regions, and for the B it's called B1, B2. And we're going to do this recursively for each iterations to keep all the parental informations like DNA. And after you have completed splitting the regions with this step, next thing you want to do is to connect these regions with a hallway or a line by selecting the which regions to connect by looking at the last areas within the parental tree informations. So you start connecting from the bottom bottom regions. In this case, A1, A2, B1, B2, and so on. And looking from the last regions, what you want to do is to connect in between A1 and A2. So connect the lines between A1 and A2, and for the B1 and B2. Okay, just like these. And after you have created these lines, you can go up to the next region, the parental regions, and then connect A and B. In this case, these regions and these regions. Now in this case, this regions and this region is a combination of A1 and A2, B1 and B2. So you choose one of the regions from A, in this case could be A1, and one of the regions from B, in this case could be B1, and connect A1 and B1 with a single line. Okay. And in the end, if you continue doing these connections recursively, you'll be able to connect all the rooms with a line, a hallway, so that you could actually go to any room by using a hallway. Sometimes you only have one way to connect from other room to the other room, but at least it will assure you to have at least one connections be placed for each room. So pretty simple. So that's what I'm going to implement today, and maybe add additional algorithm to it for more flexibility to make it a bit more procedural. Okay, so that's my plan. Let's do this. Okay, so this is going to be the final project that I'm going to create today. Probably it's going to be a bit different in the last. So you have a parameter like parameter to change how many split recursions you could have, or you could choose the resolutions of the whole area. You could also control the scale of each room. If the room is too small, maybe some connections are missing, so you might have to create the balance, find a good balance between the scale and so. The min variation is, forgot what this is, could be the variation of the splitted rectangles, how skewed it could be, or how rectangular it could be, the aspect ratio, the minimum aspect ratio for the rectangles. If this is higher, then you're going to have more square-like shape. If it's smaller, you're going to have more rectangular shape. Okay. And additional hallway is to add additional hallway. Ratio to add additional hallway so that you can have more connections in between rooms. If it's 0, this is the output from the original algorithm, BSP, Basic BSP algorithm. And I'm adding additional hallway to this just in case I need more hallway. Okay. So that's my plan. Let's do this from scratch. Right, so first thing first, I'm going to create a geometry node, starting from creating a grid to split. So let's put this on the side, and what I would like to create is this kind of splitted grid. So let's think how I could do that. Obviously, I think I need to start from a rectangular shape, so I'm going to create one for that. So I'm going to use a grid, and probably I might want to control the size of it. So I'm going to create a null node next to it to have some bunch of parameters that I want to use in the end. Right. Well, looking at the screen of the live stream, it's looks a bit too orangish. Not sure why. Let me see if I can fix it. Yeah, maybe I want to fix this. Looks a bit orangish. Okay, let me pause the video for now. Let's see. Why am I seeing these views a bit orangish. Not sure. Okay. Looks like some kind of white balance has been applied to the screen, but looks totally off. It's pretty weird. I might need to update the display color balance or something. Huh. Not really sure why is it look like orangish. Let me see. I don't know. I don't know why I'm having probably due to the switcher that I'm using right now. But I don't see any settings where I can change any white balance or something like that. Oh well. At least this isn't about the visuals, it's more about the logic, so maybe I'll just go with it. Right, sorry for this weird color, but I'm just gonna go with it. Could this space partition be used for creation of conventional floor plans? Isn't the sleep mode in Mac? Is it? I am checking. Maybe it's due to... No. I thought it was because of the true tone or something like that. No. It's pretty weird. Well, I'll just go with it. For the floor plan, I'm not sure if you could really use for a conventional floor plan, since this is more like for gaming and stuff, or rogue-like game dungeon stuff, but maybe you could apply it somehow for a floor plans as well. You are going to have a bunch of spaces in between rooms, so I'm not sure if that could be used for floor plans. Well, anyway, let's start doing this. So where was I? So I have a grid, and what I wanted to do is to have some parameters to control the size of the grid first, width and height. Right. Let's just make it 10. Also, it will be good if you can control the resolutions of the grid, meaning how many divisions you could have in the X and Y directions. That would be also good. So let's have that information as well. And that could be once I choose one of the rows and columns, the other values should be automatically calculated based on the size. So I'll just use one value, which is going to be a value to divide the width and height to calculate the resolutions for columns and rows. So res, I'm gonna make it as a float as well, and copy this parameter. And for the rows, I am going to paste it here, as well as copying the Y value of this grid and divide it by the resolutions also. Or I'll just copy this one, paste it here, and I'll copy this one and divide it by the resolutions value. Okay, now that I have an integer, in this case 8, and if I change these width and height, I could make each grid cell as much as possible to the square. But if I want to make this exact square size, then I might need to change this one based on these rows and columns. So I'm going to copy the columns and reuse it in X, multiply by the resolutions. Okay, same as these. Copy the rows, multiply by the resolutions. Okay, now the size is a bit off from the original size that I set, but you're going to have exact square size, so that might be better in this case. All right. Now let's make this 10 by 10 and make it a little bit smaller in terms of the grid. Let's also set the size of the resolutions to from 0 to 2. Okay, all good. Now after this, what I would like to do is to do a splitting algorithm. Now let's see how I do that. I could actually split the grid from a single rectangle without any cells, and I think that might be easier, so I'll do that way. Or I don't know, maybe using this itself as a base is still okay. Well, I'm just gonna make it simple. So after having these grid, which I'm going to use it later, I'm going to fuse or remove all the inner edges for now, as well as removing all the points on the edge. Currently I have a bunch of points, divided points here, so I'm going to remove it for now for grid splitting by using, what was it? Forgot what was the name. What was the name to... Wait, totally forgot. frame, no. Poly split, no. Totally forgot what was it called. No, it was called facet. Yeah, facet. Facet, and check remove end lines points. You'll be able to remove the interior points, right? Okay, now let's start splitting the grid. So I'll do it inside the for each a node by setting this up as a feedback loop, setting the for each end to feedback each iterations, as well as setting the for each begin with fetch feedback, so that it will become a feedback loop setup. And I'll start with 1. So first thing I want to do is to choose randomly whether I want to split it in horizontally or vertically. Right. So let's decide how I do that. Okay, so I could first of all I could create a conditions, or like random conditions, by rolling a dice, and I could just do it within a vex code, or I could also use it in transform node. Shall I do it in vex code, or maybe it's easier to see in node, so I'll use switch node to switch between input 1 and input 2, and for the input 1 I'm going to create the divisions for the horizontal split, and for the second input I'm going to create a horizontal split. Was it vertical split? Either way. Okay, and using transform node. Okay, so I am going to connect the original grid that I have right now to transform node, and randomly choose a scale. Well, now that I realize I'm going to need a bunch of random values, one for the scale, one for which side to pick, either horizontal or vertical, so after all I'm just gonna use primitive wrangle because I think it's easier to manage. Right. And I'll just do all the operations inside one vex. Okay, so first of all, a random switch, either H or V. I'll say horizontal. If this is equal to 1, then I'll go for horizontal split. If this is equal to 0, then I'll go for vertical split. Okay, so I'm going to use a random value, and for the random value seed, I'm going to use the iterations value from the for each number. So let's get that first. Let's have a seed parameter as well, so that you can control the randomness. Okay, and let's see if this is less than 0.5, could be horizontal. If larger than 0.5, become vertical. Right. Now, next I'm going to create a random value for the scaling for this grid. So another randomness, multiply by different numbers with additional seed. And you could, I think you don't want to have a scale in between 0 to 1, because if it's close to 0, you're going to have really thin areas. So you might want to control these values, the range. So let's control the range by applying fit01 and have another parameter like scale min. If it's 0.2, then the range will be in between 0 to 0.2 to 0.8. Okay, something like that. Okay, I think I have some errors here. So I have randomness. Maybe I needed to make sure that this is a float number, so error unexpected plus expecting identifier. Why is that? Syntax error unexpected 5. Oh, additional dot. Okay, should work. So now I have scale value and the horizontal or vertical integer value. Now it's time that I scale the primitive. I mean, in this case, make 2 primitive based on those informations. If it's vertical split, then I make 1 rectangle on the left, another rectangle on the right with these scale value. If it's horizontal, 1 on the bottom and 1 on the top. Okay. Now, in this case, I will need 2 rectangle informations, and I can make that by, first of all, scaling the original square by choosing the pivot of the scale. If it's vertical, the one of the pivot for the rectangle will be on the left side, and one of the rectangle on the right side, the pivot will be on the right edge. So let's do that. In order to do that, I could loop through all the points of this primitive first to access the point positions. Okay, get the point number, get the point position. And let's scale it. So in order to scale it, you need to set the pivot. Now, I will going to have 2 geometry to be created, so I'm going to create another loop with 2 iterations. In this case, if n is equal to 0, then maybe I want to do it for left or bottom based on those horizontal informations. And if the n is equal to 1, then right and top for the pivot positions. Okay, so let's have some conditions. Pivot is start with 0 if horizontal the pivot will be based on the bounding box information of this grid. So let's get the bounding box information. All right. So if the horizontal is equal to 1, then the one of the pivot will be minimum dot. Well, minimum's fine, I think. Yeah. Actually, this could work for both left, horizontal and vertical, actually. So the condition should be n when the n is equal to 0, else pivot will be maximum. Right, so now that I got pivot, it's time you could scale these positions based on the pivot information together with these scale. So position minus pivot, and you, what's the you also need to change the scale based on the n value. If n is equal to 0, then you just use the scale as it is. If n is equal to 1, then you're going to use 1 minus scale. So I can do it here, I think. Start with 1. If n is equal to 0, then n scale is just the scale itself. If n is equal to 1, n scale is equal to 1 minus scale. Right. Then multiply this position by this scale that you have just created and made it back to the original positions using pivot. Now that you have a new positions for a new splitted rectangle, it's time you create a new point. And connect all these points within these group to create one polygon. So finally, using add vertex to add these points to the polygon. Now remove the original primitive. Oh, interesting. It's not what I expected. Okay. I realized I should not do the scale for both x and z, but if it's horizontal split, then you only should do the scaling to the z. And if it's vertical, then you should only do the scale for x. That was the point. Alright, so I need another conditions here. If n or maybe I could just use the scale as a vector value, starting with 1 1 1, and n scale if it's for a n value, actually the scale value should be made with a horizontal or vertical conditions. So if it's horizontal, the n scale is set scale, no, 1 1 scale, else and scale is equal to set scale 1 1. Okay, now I can just multiply the position with the vector value. Oh, okay. Actually, I still needed to make the float value inside this conditions. Forgot. So when n is equal to 0, then I'll just use the scale as it is, and if it's not, then 1 minus scale. So I needed to use 2 conditions for this one. Now replace these with t-scale. Okay, there you go. So that's the whole code, and should do all the jobs with these. I have 2 parameters. One is seed. If I change these, I could change either I could change both scale and split direction. And if I increase this one so that I can control the minimum vertical width with it. Okay. To me, it doesn't look like it's going to the left side for the vertical split. So maybe something is wrong. It only goes above 0.5 to me. So maybe something is off here. Let's see why. Yeah, looks like it's always above 0.5. So maybe something is wrong. So checking up the scale value. Let's see. 0 1 going from the scale minimum to, alright, so if it's 0.2, then it will be 0.8. Okay, so that's what I need to check, I guess. Let's check the geometry node primitive. Okay, so at least in this case, this looks correct. Going from 0.2 to 0.8, that looks correct. All right, next. Let's check this one. Float t scale. Wait a minute. Is this correct? Pivot is, yeah, I think it is. Oh, wait. Actually, I think I need to specify the number of, even though there's only one primitive at this moment, I still need to specify that there's only which primitive to get the bounding box. Okay. Now I don't think that's the place where I needed to fix, but at least. Okay, next. Where should I check? Okay, let's see if I could see the value here. So you still get smaller value. Alright. So this might not be the reasons. If I make it to 0, yeah, it looks pretty obvious that it just only goes to the top place or the right regions to split. So obviously it's wrong. This is wrong. And I am assuming that pivot is somehow wrong here. The minimum, not sure, maybe not. Oh wait, it's always 0? Okay, maybe that's not correct. Am I getting the minimum and maximum? Oh, nope. That's the problem. That was the problem. So get B box is not working for some reasons. Either max or minimum is always 0. Oh wait, I need to make this. Wait, yeah, well, I do get the value for, so that's not a problem. And yeah, so looks like it's correct. Wait. But I never get the minimum value. That's because I have it here. Okay, so I do get the minimum value, which is supposed to be this place. This is the minimum positions. This is the maximum positions. Okay. So the pivot is probably okay. The position should also be okay. I think. So I'm getting the primitive points. Well, at least it is dividing, but the scale is wrong. What if I only have one side? Wait, maybe something is wrong here. And remove the final geometry. Okay, let me fix my mouse. Something is off here. Okay, why is it? I'm going to try by setting up a simple scale here for custom scale here. Let's see if horizontal is equal to 1. So currently I'm using horizontal, so if I change this to 0.3, oh no, it was vertical. So if I make this to 0.4, okay, 0.3, alright. So If it is less than 0.5, then it should go this way, but seems like it always goes above 0.5 for some reasons. So maybe where the this calculations is somehow wrong. Let's check. So T-scale 0.8. Yeah, it always goes above 0.5. Now that I realized, if it's the pivot is maybe not. Why is that? If I make the scale nope. That means scale is always above 0.5, and these are created right here using fit 01. But this is supposed to be in between 0 to 1, isn't it? So this is 0.4 and okay, this is still 0.4. Wait a minute. 0.04, yeah. Point 0.78. Okay, seems like these, if this is smaller than 0.5, then it's always horizontal, and if it's larger than 0.5, it's always vertical. So maybe the conditions that I made somewhere is wrong. Yeah, I think that's it. And that's probably where I set this one. Okay. Okay, so the way I made the scale is using these values here. So it seems like this. Okay, maybe I need to check how it's being related. So if the horizontal, and let's cancel all these for now. So if it's horizontal, it's 0, meaning if it's vertical, it's 0.8. If it's horizontal, then it's 0.2, and it's always less than 0.5. Okay, I guess that's the reason. I thought I changed the seed, but maybe it wasn't enough. I'm going to multiply the seed by another value here. Make it big enough. And additional value to be added. So hopefully this will change the connection or if it's horizontal, 0. If it's vertical, larger than 0.5. Okay, now I get another conditions if the horizontal is 0, scale is less than 0.5. So this should fix the problem, hopefully. So that was the problem with the random seed. Didn't realize that. And I need one more geometry, so make this back to 2. So let's change the random seeds. Okay, now it goes more diverse. Alright. Now it took a lot more than I thought, but yeah, at least I get these divisions. Cool. Alright, that's cool. And what was I trying to do here? Okay, so that's the divisions, and let's see if this could work recursively. So this is the first iterations. On the second iterations, okay, obviously I need to change another random seed on different step. Okay, so I should, well, at least I do have a iteration value here, but I guess I need another value to change the random values based on the position of the grid. So I'll just add a p value to it, the center of the primitive. That should do it, I guess. Yep. Now let's check by creating a lot more iterations. Alright. Now I do still have some problem here, because as you can see, you have some conditions where the height might be too thin, or width or height might be too thin. So I need to fix those conditions. So let's add additional conditions to restrict the minimum lengths of each edge, which I wanted to use this one as the minimum range, but didn't really work. This is just a ratio, so you also need additional restrictive lengths limit value. So if for the edge, so if the edge is smaller than the divided, smaller than the limiting value, limiting edge lengths, then on those primitive you might want to skip doing the splitting. So let's set min edge then. Let's make 1 as maximum for now. I'm not sure what's the right value for now, but let's copy this, and I'll just do it in this primitive wrangle. So let's have that value as a parameter. And see how I should update the code. I don't need this anymore. Oops. So in order to use this minimum edge length, I need to know the actual length of the splitted edge. And splitting happens on the scale here. Okay, and you could estimate the size of the edge by calculating the bounding box size with this scale. Right, so let's do that. to do that, you need to have a bounding box size. Actually, this is kind of a heavy operations when you use I2A as a group filter, so I'm going to estimate the size from minimum and maximum, which I already have it. So this is the size. Okay, so going back to where I do the scaling. This is necessary, not necessary. So I'm using this final end scale as a final scaling value for the bounding box, I mean the grid. So I could scale this size with this end scale here, or I could just do it beforehand when I already got the scale value somewhere right here. So vector scaled size is equal to size multiplied by scale, and check the size for x and z for this scaled size. And if it is too small, I mean if it's smaller than the scale mean, then you might want to skip creating these additional primitive. So let's check if scaled size dot x is less than min edge length, or scaled size dot z is less than min edge length. Then do nothing. I mean, you don't really need to do anything, so maybe I'll change the condition. If it's larger than the minimum edge, then only if then you could create those additional primitive, as well as deleting the original primitive. If not, you can preserve the original primitive. And if I enable it, now you can limit the size of the minimum edge, I mean maximum edge. Well, seems like in some part it's not work. Well, wait, this is not the one I need to change. This is the one that I need to change. Okay, so I guess doesn't seem like it's working, especially for the vertical one. Yeah, vertically it doesn't look like it's working. I gotta check if the axis is correct. So it's xz, so that's correct. Although at some point the conditions is not working. Let's check from 1, 1, 2, 3, and interesting. Obviously this looks totally wrong. Maybe the way I get the bounding box is wrong. That might be the reason. Get b box 0 I2a primitive number should be it. The size is maximum minus minimum. I think that's also correct. And if, let's check what's the size of it. For a moment, I'll remove these. Okay, so So I do have these scale size, which is smaller. I mean, yeah, smaller than the one that I applied here, but not sure if it's been skipped. Yeah, it is being skipped. Although something is kind of wrong here. Okay, I'm gonna check by copying these value here and check it with another primitive wrangle to see the size of the current bounding box. Okay, and yeah, obviously I have one that is not. Okay, now I realize that I actually have to check if the scale that I'm multiplying here is less than 0.5 or more than 0.5. I kind of need to use the one that's less than 0.5 in this case in order to check. I think that's the reason. Okay, so going to make a conditions. And if it's true, then you use scale as it is. If not, use 1 minus scale. Okay, how's this? Check again. Change the seed. Okay, now I think it looks more correct. Yeah. And for the seed, I'm gonna change this to integer. With a big range. Okay. Yeah, I think it's working. Alright. Well, sometimes you get really big rectangular value here. Now, what if I increase the iterations here? Does it changes? I mean, I was hoping this would be splitted in some iterations because these are too long here. So, but it doesn't happen for some reasons. So maybe I want to fix that as well. So that at some point it will be splitted and it go until it goes a little bit above minimum edge length. Okay, so gotta check why it's not being splitted, even though you have a big areas here. So let's check. And that's also probably due to these random seed. Even though I changed the iterations. Wait. 1, 2, 3, 4, 5. At least this code works for every primitive at this moment, so should also apply to this here for each loop. It doesn't really doesn't change at all. Am I getting the right value here? That's one problem. Wait. Something is wrong here. Why it's getting so many time to process it. Huh. Ah, that's because I don't have a remove one. Okay, cancel, cancel. Cancel it. Meanwhile, well, I still don't like the color of the display. Why am I having these brownish screen? Hello everybody. I want to see one done in Blender. Well, I don't know how. I don't know Blender much. I do want to learn it for sure. I heard geometry node become much powerful than I last touched. So maybe if I could do that, that'll be much interesting. So where was I? Yeah, I wanted to control these size here. And well. And I wanted to check if the iterations is set correctly. Let's check like this. Looking at the detail attribute. Yeah, the value is changing. Okay. So it should be okay in terms of the seed value. What else I could be missing? Okay. So if I connect this one again to this one, doesn't really change. Right. Now, what happens if I remove this conditions here? So at least you have these split here, but why it didn't keep it? That's pretty. Maybe the condition is not well written here. Let's check. Oh, there's a comment. You can also do this with lab slot subdivide. Yeah, I tried it, but it has less control I wanted to use, like setting the minimum edge lengths and so on. I wanted to add a bunch of custom like conditions to the divisions, so I couldn't use that node. Okay, so this is it? Well, this is larger. This is larger than. Okay. Well, I'm just looking at the one primitive, so it doesn't really help, I guess. Maybe the condition that I set was too big. Maybe that's the reason. If I make this little smaller. Might work. Yeah. But still looks a bit weird, eh? Okay, I'm going to refine the conditions. I was always looking at the X and Z at the same time, but I'm just gonna change it based on if it's horizontal or vertical. Okay. So if it is horizontal, then I'm going to look for the X value, the Z value. So if it's horizontal and if the scale size dot Z is more than minimum edge length, then you could do it. You could do the divisions, or if it's horizontal, if it's vertical and scaled size X is more than min edge length, then you could also do. Alright, now this looks much better. Maybe that was it. Okay. Okay, this looks much better. So I can change the width, height, resolutions, doesn't really matter in this case at this moment, and I could change the minimum edge lengths. Okay, let's promote all those parameters that I set. I have a seed, random seed value. As well as scale min, which is not that important, but let's have it. And minimum edge lengths, okay. And you also want to control the number of iterations for the recursive. Okay. Now for now it looks good. Now it's time to apply some DNA informations to each of the boxes, which is another reasons why I want to use it. We use a custom Vex code instead of using LOT subdivide, because I want to apply these custom attributes to each node based on when it's being splitted and what's the parent of its original split its box. For this box, this is the parent, and so on. So I want to have information like this as a DNA to each boxes. And what I'm going to do is set the DNA something like AB, 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 AABB, and something like that. So first one is the top parental geometry informations, and the second one is its children, and its children, and its children. And you always have either A or B because you split it into two. Splitting the geometry into two for each primitive. So you're always going to get either A or B. So I'm going to apply this DNA text or gene to its primitive on each iterations to specify how it's being created from which parent from previous iterations. So let's do that again inside this code. And first of all, you need to have a original gene information. So let's create that attribute outside the loop. Okay, and let's call this DNA. And for each primitive, string. And I'm going to make the default value to be A, since there's only one in this case. Okay, starting with A. In the loop, I'm going to, when it's being splitted, one of the splitted geometry will be having A as appended to this original A, and another one is going to have B appended to this DNA. So that's pretty easy. This is where you are creating the primitive here, okay? And you're specifying the which primitive stands for A and which primitive stands for B by checking this n value. You could say if n is equal to 0, then you are going to be having A as a additional DNA, additional gene. And if n is equal to 1, then you're going to have B as additional gene. So if, first of all, let's get the original gene, DNA. A string DNA prim DNA. Now, if n is equal to 0, then set prim attrib, or I could just say new DNA is equal to DNA plus n based value. So if n is equal to 0, you're going to use A, otherwise B. Okay, then set prim attrib 0 DNA. Set the new DNA to this newly created primitive with this new DNA value here. And let's check. Okay, so here goes. So each one has its own unique gene here. And you can check the last value for each DNA to see which one should be connected in which iterations, and which also has to share the same parents. Okay, so now I got the DNA. It's time you leave this loop and start creating the connection. But before that, I might need to go scaling the square first. Okay, so let's do this. So scaling is pretty straightforward. You just pick each primitive and set the pivot for the scaling and randomly scale it with some value, with some scaling value you provide. Okay, now before doing the scale, I want to fit these squares to this grid that I have set previously, which in this case it's a bit high, low res, so I'm going to make a bit high res. Let's make the maximum 1. So I want to fit the point position of each box that I created here to this grid, since this is going to be the final grid base that I'm going to use to create a dungeon. So pretty easy. I want to use a point wrangle to fit, define the closest point to fit or snap. Just going to use a new point. Just find the closest point and use that point to snap. Okay. You see the difference? It's been snapped to the grid. Now it's time you do the scaling for each boxes, which can be done both either for each loop or primitive wrangle, and I'm going to use primitive wrangle. It's gonna be because it's more compact. Yeah. So looking at these, how it's been scaled, I can see that the pivot position of the scale could be random within these areas, as well as the size, the scaling value for X and Z is also random. So let's keep that in mind. And in this case, you still need some minimum edge length information so that it won't become too small. Right? So let's do that. Scale, room. Okay, so for each box, let's first specify the pivot position. To do that, I'm going to create some random vector value here. First, based on maybe the center point position of the primitive, maybe plus seed, just in case you want to change. And I'm just going to use this seed value to control the randomness. Okay. Now, the range of this pivot is in between 0 to 1 for all X, Y, and Z. And I want to change the range so that it will fit within these box region. So what I need is the minimum point position of the bounding box and maximum bounding box positions, just like we did last time. So I'm gonna use a bbox, get bbox. Make sure I'm getting the current primitive number bounding box. Okay, and fit the pivot to minimum and maximum, so that the pivot position for each primitive will be within this box. Let's check that. I'm going to add a temporal point to see where this pivot is being created. Okay, yeah, seems like it's working. Every point for primitive is within this primitive. This is on the edge, but still within the primitive, so I think that's fine. Okay, now that I have pivot, let's also create a random value for scaling. Let's create another randomness, and also shift the randomness a little bit so that you get different numbers between this one and this. Okay, this is also in between 0 to 1, so which is okay, I think, which is okay. I could just use it as it is. Let's see what happens with these. I might need to control the range of this scale later. Maybe having 0 from 0 is gonna make this too small, so we might need to control it, but let's see how it goes. So now that I have scale and pivot, it's time I control the point position for each primitive. So let's get the point information. Get the point position, and then subtract it with the pivot first, multiply it with scale, made it back with the pivot, see what happens, and update. What's this? Declaration of variable PT shadows. Do I have it previously? Oh yeah. I don't need this line here. Okay, now that I have an updated positions, it's time I update the current position with these. Okay, obviously some of the box is too small in one direction. So obviously I need to control the size of this all scale. Okay. So maybe the size could, maybe I could parameterize it, but first of all, the size of the edge must be at least larger than the edge length of this one cell. I mean, one cell is the minimum size of the edge, I guess. So let's get the edge size of this cell and have it as a minimum value as a limit value. So how can I get that? So that is a size value divided by rows, or you could just use this one. This is the actual size, I guess. So I'm gonna copy this resolution value, have it right here, and use this to control the minimum size. Okay, so which should be done after I have it here, I guess. So I need to convert this resolutions value into scale. Okay, in order to do that, I need to know the size of the box. So again, calculate the size of the box. Okay, now let's see the minimum scale from this size. So I'm gonna change it to the scale value. So sorry, the min scale could be a size. Actually, it's set. I'm not sure if you could do the divisions between vectors, maybe not, I don't remember. I wanted to do something like this, but I think it does not work because the first one is the float, so I have to, at least I have to make this as a vector value, I think. Okay, let's check. Okay, at least I do get some numbers, so hopefully this is correct. Now that I have a min scale, I can clamp the random scale with this minimum scale. Or using the max function. Okay, let's see how it goes. So now that I have this minimum edge numbers, at least the minimum edge length becomes more than one cell size, which is still not looks really natural for a dungeon room, so maybe that wasn't enough. Another things that I could add is a scale range for this randomness. So I could say fit 01 all scale have two values, min scale and max scale. And let's say minimum scale is 0.5 and max scale is 1. Now it looks a little bit better. Okay. Now I might not want to have these touching situations happening for the neighbor rooms. So if I want to preserve, if I want to preserve some space between the rooms, then I can go back. I can always go back to create another scale value, which in this case max scale for clamping. So in this case that will be size minus set res divided by size and then instead of using max I can use clamp to clamp between minimum scale and max scale. Huh. Well, didn't really work. Let me make this maxed out. Okay, so what if I set this to 1? What happens? Okay, so at least I did get the spaces, but didn't get the space here. That is because the pivot, it's because of the pivot position. So I also need to change the pivot positions. If the pivot is on the grid, then it's always going to have a touching, always going to have a chance to get this room touching thing happen. So I think I need to control the pivot positions as well, which is this one. So let's see if I could just say from the minimum I can add set res. For the maximum I could subtract the resolutions. See if this could work. Just a little bit. Maybe not. Let's think about the other stuff. Well, I could create the actual minimum bounding box, and I mean minimum size, minimum position, and maximum size for the bounding box by having minimum added with the resolutions value for both x and y, x and z, and new mux subtracted by resolutions both x and y, z, and for the pivot, I think that's fine. You don't really need to change it. And after you had the final positions here, you could actually clamp the position with this new bounding positions by just using clamp. There you go. Oh well, that's a bit too much, was it? Okay, this looks better. So at least you're going to have at least 2 cells space in between the rooms in this case. If you only want to have 1 room space, then you could just multiply these by 5.5. Like that. But anyway, in the end, you're going to snap this grid to square into the grid, so I think it's safer to say you have at least 2 spaces, well, which you could always control by going back here. Alright, looks good. Now, let's go back to the controller. See what happens by changing those values. See if I get any errors. Okay, it's always getting some errors here. That's because I already have one space here. If the minimum edge length is less than the resolutions, then that's going to be a problem. So this value always needs to be bigger than this one, which I could have some clamp value somewhere. Maybe I could set the logic here. Minimum edge length must be bigger than the resolutions. So let's give resolutions value, bring dot, seed already exists, replace it. What do you mean? Skip. And copy the resolution value to here. And the scale minimum edge length has to be bigger than the resolutions. Maybe multiply by 2, just in case. So you'll, the minimum is always maybe a little bit more, 3, 4. Yeah, this is about the right value, I guess. Okay, so now it goes pretty much fine, even if I make this smaller. Okay, seems to work. All right. So now that I have these infos set, it's time I create a connection between the rooms. start with these. Okay. It's a bit hard to control here. I might need to add additional conditions later, but for now I'm gonna go with this. Okay, so I'm gonna take some break at this moment. Let me know if you guys have any questions. And while I take a break, let me check again why am I having this weird color to the output. I'm not really sure why is it. I think it's due to the controller that I'm using, or is it? Let me try changing the output positions. I'm gonna go blacked out a few moments. Okay. Still, this could be a problem with a HDMI cable itself. Let me change that as well. See? Where is my cable? Can't find my cable. There we go. Okay, it's gonna turn black for a moment. I'm gonna reconnect the cable. See if it's gonna work. If not, then gonna be some other problem. Well, still orangish. Maybe it's not about the cable. Okay. You snap before scale room. Do you need to snap again or only snap once after scale room, since the points are currently not shaped? You're correct. I do need to snap after this as well. So let me do that. Before connecting the rooms with hallway. Let me check another cable, see if it's gonna work. If it does not, then I am doomed. Nope. Guess it's the problem with the switcher that I'm using. So I guess I need to fix that later. Not sure why I'm getting this. Anyway. Anyway, I'll just continue for now, since I cannot figure out how to fix this weird display color. Sorry for that. Okay, so like Alain is saying, I am going to snap it. Just use the same code that I have it here to snap. Now I might not need this one, but let's see if I get some differences. So I do see difference when I have the snap or not. I think it's safer to have a snap here because you're going to create the scaling based on the grid, this original grid. And again, having another snapping is going to make sure that it's going to be fit within this grid. So that's my approach, but I guess you could also you could skip this snap, the first snap. I was wondering if it's still gonna work. Maybe I thought this, without having this might going to give a direct connection to the room. I mean, no space between the room in some cases. But seems like it doesn't really happen, so maybe it's fine after all. Yeah, seems good. So maybe you could, I guess, skip this one. Yeah, and I guess it still works. So let's make this come here then. Okay. Okay, now that I have these rooms created, it's time I create the hallway based on this DNA that I have attached to each primitive. Okay, these. So, first thing I want to do is to sort this DNA based on its strings, and then look for a children value, which is A and B and shares the same parent. In this case, this one and this one shares the same parent, A, and the children names is A and B. So these two children should be connecting to each other. And once it's being connected, then update its DNA so that the A and B is going to be removed and become one AAA, its parental DNA. So once you created the connection between two rooms, it will be merged as one primitive and become one single parental DNA by removing the children DNA value, gene value. Okay, so let's do that. Let's do that, and at this point I could either use this grid itself or bring these grid to be modified within the loop, but that's, I think having many grid might make the calculation time a bit costly, so I'm gonna go with these simple grid first, then later split it into this divided cells. Okay, so shall we do that? First thing first, sort the primitive based on the DNA value. Okay, let's check. So the operation that I'm going to do now, it has to be done recursively again. So previously I was splitting recursively, but in this case you're going to recursively going back to the original geometry, which is the single square. So once you have a connection between two children, it's going to become one, meaning merging these two grids as one. Then again to the next step, we're going to merge it together. Then again merge it together, and finally you get just single one grid. And that's when you stop connecting the hallway, connecting the rooms with hallway. Okay, so for each number, okay, and yeah, let's see. And actually, if I could apply the iteration number to each primitive where I created here, in which iterations it's being created, then I could actually use that to specify in which order these primitives should be merged, I think. But yeah, I am not sure if I'm gonna do that. Maybe I don't do that. I'll just go from scratch. Let's see that I don't have that information and see how I could do this. Okay, so within the for each loop, I am going to make this a feedback loop again. Now, first thing I'm going to do is to count the lengths of the DNA genes and get the maximum out of all the genes. Meaning, if the length of the DNAs is 7 and 7 is the maximum out of all the DNAs, then I'm going to get the primitive which has 7 lengths of genes. And apply connect the hallways, connect the rooms with hallways for only for those long DNA values, DNA rooms. And after you have created the hallway, then you're going to trim the bottom value and merge it with one DNA, in this case just AAA. And so in the next loop, the maximum number of DNAs become the current one minus 1. So let's check the lengths of the primitive DNA. Gonna give a simple wrangle to calculate the length of the string DNA. Okay, in this case, maximum is 8, so I only want to get this 4 rooms, which should share the same parents for this one and this one. Okay. So to do that, by promote the maximum attribute value from primitive to detail, get the maximum max length DNA. Now I get this 8 as information. Now it's time I split this primitive into two, one for the hallway connection and one for the skipping. So I'm going to use a split node and check if the length is equal to the maximum or not. So then DNA is equal to the expression detail current primitive, current geometry E max then DNA 0. Okay, something is wrong. Unable to evaluate. Okay, must be something's wrong here. So the name, let's check the name, the len DNA. Do I still have it? Yep. And the max len DNA. Okay. OP input, detail. Oh, forgot to have 0 here. Okay, why am I still having errors here? What's the error? What is... oh, disappeared. Okay, so the first output is going to be the one that I want to have a connection between. And the second one is the one that's going to be skipped for now. And in the end, it's going to be merged and go to the next step. Okay, so now that I have these stuff, it's always a pair to connect, and it's already being sorted, but I guess it's a good idea to sort it right here again. Or maybe I don't really need to sort it outside the loop. And now it's been sorted. It's time you pick from top to bottom, just choose the pair. The first two will be first pair, the second two will be the another pair, and so on. Okay, and to connect the hallway. Yeah. So let's do that. I could use primitive wrangle, I guess. To create a simple line to connect those two rooms, just to test. Okay, let's see. So there needs to be some conditions. Since it's always going to be a multiplication of 2, right? If it's not the original box, which is just one plane. So first thing first, let's check if the total primitive number is total primitive number is a even number or not. If it's even number, then I can go. Now, the first primitive value will be primnum. And the second one could be primitive number plus 1. So I'll need another conditions here, and if primitive number is even number as well, so that should be the condition that I have to set here. So in order to pick just 2, if I have 4, This condition works if you have 4 primitives, then and the number of, based on the number of primitive, this is 1 0 0 1 2 3, and this condition only picks if the primitive number is even number, so you only picked 0 and 2. And you're going to add these value by 1, so you also get the neighbor numbers as well. So that's going to give you 2 primitive value. Now you could get the center point position of these primitive with prim1 and prim2. Now, actually, for this one, you can just say at P. Now you could add a new point to the center of each primitive. Create a new line. Oops, something is missing. Okay, like that. And currently it's straight line, so that's fine, but when the room size is different and when the pivot is different, then you're going to have a diagonal line. So maybe for those lines I want to fix that later, but for now this is the simple connection that I could create here. So let's try with this first and fix the detail later. I'm going to set the group to this line, calling hallway. Okay, and yeah, now after having those 2 values being connected, like I said, I want to update these DNA value, trimming out the last gene and merge those 2 primitive as one to have single DNA value. Okay, so to do that, I'm gonna set those 2 geometry as a packed geometry, or yeah, I'm gonna use a packed geometry for that. So to do that, first thing first, I need to pack these 2 geometries, and I think it's also a good idea to set the group for those 2 primitive as well, or set the primitive information so that I can use it with the pack. Pack needs a string attribute called name, so I'm going to set the name to each primitive which shares the same DNA. Actually, I already have DNA as a string, so I could just use that actually. Now, after creating a hallway, I'm going to split it again to separate the hallway and the rooms. And for the rooms, I'm going to connect with the pack it with the DNA value. Now, as a result, you are going to get 2. Oh, before doing that, I have to remove the last genes from the DNA. So primitive wrangle, update DNA. So I need to use a substring for this one, I think. And what was the, forgot how I could do that. Something like this, was it? Yeah. So I have just trimmed the last character from this DNA, which made these two children sharing the same value. So that now I can use pack to gather those two children value sharing the same DNA to one geometry. Then let's also transfer the DNA. Right. Now, after this, I think for at this loop, it's pretty much done. You have hallway and connected to here. Now, you still need to do several things to do for the next loop, because you haven't considered how to connect the rooms which is being packed in the next loop. So let's see how we do that. In the next loop, so this is the first loop. You only had two rooms being connected. In the next loop, going to have a bunch of other rooms being connected, but you see they are going to have some problem here, because you are trying to get the point position from the center of the packed geometry, which is sometimes on the hallway itself. So it's not a good idea. So let's pick one of the rooms which is close enough to the neighbor primitive and connect it with those two rooms. So, which is also done here, I think. Well, in this case, it is connected to the hallway as well, so maybe that's also fine. Maybe I'll do that. Okay, in that case, let me think. So this is the second loop. So you are again calculating the length of the DNA for each string, getting the maximum, splitting, getting the maximum length DNAs. In this case, the next loop will be 7, and sort it out, create a hallway. Now this is where I need to change, I think, because it's relying on the packed geometry center, which, as you can see, previously this was being packed, and in the next loop you have this geometry, and if you get the center of the packed geometry, you get something like this, which is not a good idea, I guess. And you also have a hallway informations coming out of here, so let's also split that information. And I guess this hallway, if you want to connect with the hallway as well, for the next hallway, you might need to pack that hallway together with this geometry, these paired geometry. So shall we do that? So to do that, I need to apply this DNA informations to the hallway as well. Right. So maybe I can just update the DNA right here, right before creating the hallway. Then apply the same DNA to these lines. And forget about these. And also forget about the split. Just pack it all together. Now as a result, you get these two primitive plus these lines as one packed geometry, I think. Let's see if that is the case. Nope, wasn't. When I packed it, I get 3. How is it so? So currently I have, oh, wait, wrong attribute. Okay, this should do the job. Alright. So now I have pairs, which include both rooms and hallway. Alright. That's good. Now, going to the next loop. So let's think how we could actually connect between the packed geometry and another packed or a primitive geometry. So right here I have, so currently this one should have a even number value, even number primitives, but maybe it will be easier if I could split it into left and right, or use the split to say which one's A, which one's B, so that maybe not. Let me see what could be the best way to deal with these. I mean, I could always use for each loop for that, for sure. Maybe that's easier for in this case, since I'm using packed geometry. Yeah. Okay, let's use for each loop for this one to make it easier. So instead of using just one single primitive wrangle, it's gonna be a bit cost inefficient, but much easier to control. So you going to loop a half size of the total number of primitive coming out of the sort. So let's refer to that node. Point 5. Okay, which is going to be 12. And for each loop, you're going to get what you want to get is the even number value and the odd number value. So I'm gonna use primitive wrangle for that, just to pick specific geom. Or just use delete in this case. Maybe not. Sorry. I'll just use primitive wrangle, get the iterations value, pick 1, pick A, and pick B. For the pick A, if primitive number is not equal to the iteration value, and just remove it. Just to get one primitive. Again, for this one. Okay, and also I might need to multiply it by 2 because you only have half size loop here. And multiply by 2 by plus 1 in this case, you get B. So this one and this one should always have A on the last or B on the last and shares the same parent. Okay, now it's possible that I use packed geometry, so let's unpack all. And so you have two geometries being splitted like this. Now I think this will make it a bit easier to find the connection between two geometries. So what I would want to do is to pick one of the geometries and search for the closest distance, I guess. The way to create the connection could be in many ways. One of the way I tried last time is to get the center of the primitive room, which is fine, but there's always a chance that you have multiple number of rooms and hallway as well. Since I also going to have a hallway information as well, in this case, I could get each center from primitive, from rooms and hallway, and use those as a an option, a candidate to connect between these two. So what I'm going to do, I'm going to create center point positions for each rooms and hallway like this, and just remove the original geometry for now. Do the same for the B and connect these 2 points together if it's in the closest distance. How do I do that? Just kind of want to search all the possibilities between those 2 point sets. So I don't know, the easiest way is to just pick all the points from the second input . Which doesn't sound efficient at all. I might want to change it later. Well, let's see. The position 1 is at P. Position 2 is point second input PI. And then create new point. Connecting these together and calculate the lengths of those created lines and just pick the smallest one. Okay, in this case I only have one primitive for each, so just one line, so it's not that special. But what I want to do is to calculate the perimeter or lengths of each edges, sort it out with these primitive edges. Okay, now it's tons of node. Maybe I want to remake it with a wrangle after all, and just get the smallest one. And this will be the chosen hallway for these two connected, these two primitive. Now, so these are the bunch of hallway that I have just created. And let's see. For the original sorted, it's like that. And for the line that I've created, what I want to add is these DNA information as well as hallway group. So add the hallway group as well as a DNA information transferred from the original geometry, which is done. Wait a minute, I forgot to update the DNA this moment. So after I have sorted out, I need to remove the DNA, update the DNA. Maybe I can do this here. Right, now for each lines which being created here, I can attribute transfer the DNA informations from right here. Just transfer the DNA informations and forget about the distance threshold. Okay. Now, each line should have different DNA value as well as having hallway group. Okay. Okay, so instead of having this one, merge the hallway together with the updated DNA value here, which can come from here, and pack it with the DNA string. Okay, now let's see what happens. This was a bit too long, but see if it's gonna work. So this is one first loop, second loop, so you have a connection between the room and the hallway like that. Third loop, fourth loop, and it does seem to work until the end. And in the end, I think the DNA value becomes empty, and that's when you stop. Okay. See that it's going to get smaller and smaller. So that's that, but for now I don't really like the angle of the hallway. In this example is creating a rather straight hallway, so I probably want to make it straight. So let's do that. And to do that, what I would need to do is to update where I'm creating the connections, which in this case currently I'm just using the center, right? Center, but that's not create connections. Why it's okay? Let me look at something like third loop. Check the create connection. Sorry. Let me check for each loop. Seems like I only... Okay. So this is a good example here. I have 1 point on this one side, which comes from one primitive, and on the other side I have 3 points, and it's connecting like that. Now choosing the smallest length line is fine to me, but then when I have this line, I want to make it straight as possible to connect those two primitive. Now let's think how I could do that. I mean, I could... there is a chance that it's gonna be really diagonal, so let's see if I could see more. Yeah, this is a good example here. So I gotta think of how I can make this straight as possible. If it's not, then make it turned edge, turned curve, meaning going like this. Okay, so to make it straight, after I got the line, I could search for the intersecting edge of both two primitive. And then out of these primitive, I could search for the place where I can create a single line. Think. Okay, so this is unpacked version. This is another unpacked one. What I'm gonna do is to use poly path to both option. Okay, then calculate the intersections between this line and these edges. So after doing the poly path, I'm also going to use the convert line to convert edges into a bunch of lines, including the hallway. Okay. Now let's do the intersection analysis. The first input, I'm going to connect the hallway that I've created, temporal hallway, which will create intersection point information and I'm going to output all those information attributes for analysis, and do the same for the second input, the B. And let's check. So I have a point which indicates which primitive has been hit by this intersect analysis, and which is this source primitive, a second one. So if I pick the number 7 from this edges, I can get the one that's been touching with this hallway line. So let's do that. Connecting here, connecting here. First of all, primitive number is, what was the name? Source prim which is in the point, so source prim, which you will get a arrays and you can just get the first one, I think. Yeah, let's try with the first one. There could be a chance that you get multiple number of intersections. So if you have that, then you might want to have the shortest distance one. So in case you have multiple numbers, I'm going to loop through all the intersected points. Okay. And you can get the point positions. You can also calculate the distance from the from the starting point of this primitive. So let's connect this one as well. Wait a minute, I don't really know which one's the starting point actually. Right. So that's not real. That doesn't really solve the problem. Oh yeah. Well, I'll just pick everything. Okay, and primitive number that I want to use is the second one. And if the prim is not equal to primitive number, then well, I shouldn't do the deletion here. But since it's inside a loop, I should do it after the loop. Okay. Oop, deleted everything. Oh, need a condition if del is equal to 1. Okay, so get just 1. Do the same for this one. The type A. I don't really need the third input. So now you get 2 lines which shares the same intersection with the temporal connecting hallway. Now what I want to do is to create a vertical connections between those 2 edges. Yeah. And to do that, I think it's a good idea to divide this line by the size of the resolutions, which is because the polygon is coming from the already being snapped here, which I realized that I also need to snap the hallway as well, but later. Copy this resolutions, paste it to the lengths, which should evenly divide the curve with the size of the grid. Yeah, like that. And do the same for this one. Now it'll become easier for those two sets to connect to each other. What I want to do is to find the one of the edge on this resample curve, get the corresponding vertical or horizontal neighbors with the second input, and just connect it there. So first thing first, let's let's get the candidates for the group A and group B. Yep. So now it's getting really long here. First I'm going to convert this into line, or if I can just do it within Wrangle. Yeah. I guess I could. Let's see. I do need to use a randomness, I think, since I have several candidates to connect a minimum distance line perpendicularly. So when I use random, I always want to use vex. So I'm just going to connect these, convert it into line for now. And after this, I'm going to use a primitive wrangle to find out the best candidate using randomness. Okay, so maybe wait. Primitive wrangle, one primitive wrangle wouldn't be able to solve the problem, I think, because you need to calculate the distance. Yeah. Wow. First of all, calculate the shortest distance. XYZ distance to the second input, and do the same for the second one. And if you look at the first one, these are the shortest distance one, 1, 2, 3, 4. 1, 2, 3, and the other one is a bit larger, so just want to get those smallest candidates out of all. So now this one and this, I can't say if these are the same lengths or not. There's small differences here. But anyway, I need to set some threshold here. Another primitive wrangle. say long. And I need to have a shortest distance information here. Doesn't look efficient at all. Detail, minimum, shortest. I get the shortest distance here. Okay, now I can check if the short distance is smaller than the detail value. Shortest D. I mean, no. Larger than the shortest distance plus a small threshold. Then remove it. Now you get only 3 here. And for this one, you also get 3 corresponding lines. Okay, like that. Is it correct? Why do I have a split here? Is it because I'm looking at 3 dimension? Maybe. Nope. Something is a bit off. Wait, why? Okay, seems like my division, the resampling value is wrong here. Obviously. Why is that resample? So I was using resolutions. I thought this was the size of the grid, but it was not, maybe. Wasn't. Nope. Okay, I think I need to fix things that I wrote here. So the rows and columns, maybe I needed it to add 1 here. Nope, that's not it. -1. And need to refresh the loop. Check again. Nope, still wrong. Maybe it was plus. Nope. Okay, so I am using these resolutions here. Yeah, to divide the height and width. That's fine. Maybe I needed to change it here. Okay, so the size is nope. Is it minus? Let's see. Okay, I think I'm doing something really wrong here. I wanted to have this resolutions as the size of the grid. Let's make this easy to see value like 1. Okay, and if the width and height is 9, currently the rows and columns is 10, 2, 3, 4, and currently there's only 9 here. Okay, so it looks fine. Looks correct. If I increase another size here. So if I have these 10 by 10.1, yeah, looks correct. And so this one is on the grid. Now, but if I make this resolution smaller, somehow it's not on the grid. Oh, it is on the grid. Okay, I think I need to go back to the original. Okay, where was I? Well, something is wrong. This resampling. The edge lengths. Well, let me check the edge lengths here. Supposed to be the same as the rest resolution lengths. Yeah, it is. Okay. Now I'm confused. Why it didn't get the... First of all, is this primitive on the... Yeah, it is. It is. And when I did the resampling, do I need to make this turned on? It's weird. If I converted the line, what's the length here? It's a bit smaller than the one that I set. Maybe it didn't really divide it evenly. So maybe instead of using lengths, I need to set the segments based on the current lengths. To make it sure that it's being divided with the specific number. Maybe that's a precision error or something. That's what I imagine. So prim wait a minute. If there's multiple number of segments, I cannot do like this. Damn it. Okay, so can I change this as an attribute? I don't think so. Well, what I could do is to have some threshold here, make it a bit small, subtract with a bit small value here to correct precision errors here, which I hope would solve the problem. Yeah, no, still not, still no. Or should I add it? Now it seems to fix it. Okay, this might work. Let's check this one as well. That's the downside of using meshes, I guess. You always have to deal with the precisions. Okay, now it seems to fix the problem. Wow. Now I have created the candidates for the A and B. It's time I choose which one to pick. Alright. For that, I could just use actually, I think I need to connect it here. Yeah, so that I can have those columns being and the number of primitives to be the same. Okay, now let's connect these two together, randomly choosing. First of all, let's choose the random number by using an iteration coming from this loop and this loop for the random seed. And use it as a seed information for the randomness. I think it's always better to multiply by prime numbers, but additional seed. and some additional value. Okay. And this is in between 0 to 1, so multiply this by a total number of primitives, and finally floor it to get the index value, which you're going to keep. If primitive number is not indexed, then remove it. Actually, you can just remove everything, since you only want to create the line here. Now, if it is equal to index, you want to create a line between A and B. So get those two in positions for the line. One is the center of the edge. One is the other edge, which first you need to get the primitive number from the second input, but it's easy to get using x, y, z dist. And this t prim is the target primitive that you want to use. So like that, and then add a polyline between these two positions, which I need to make it as a point first. Alright, then PT1 and PT2. Okay, so that's just that. And since I want to make it as a hallway, set prim group hallway 9-1. What else? I need to set the DNA. And do I have that information somewhere? Yeah, right here. So I can just transfer the attribute DNA from the current DNA. There you go. And you get the line connecting these two primitive yeah. Okay, now I think I can just go like this. Okay. And actually, before doing the pack, I can unpack the original one just in case that I don't do the same packing for same DNAs again and again. Okay, so how's this? Let's see. First input doesn't seem to work. Okay, another check. Okay, so for the first loop, so these are the candidates. I have 4, yeah, and then for each, so I have 2 loops, and I didn't get any connections here, so there's some there's going to be some problem here. Okay, what am I doing wrong here? Pick A. First of all, picking, oh, Okay, so this already is deleting everything here, which is totally wrong. Let's check the first. Wait a minute. This is why it didn't work. I had to uncheck single pass here. Okay. Now it goes 1, 2, 3. No, just 2. Just go 1, 2. Maybe it's due to the unpacking numbers iterations. Let's see if that's so. Nope. So 0, 1, 2, 3. So 3 didn't work. Let's see why. So in 3, we have these two groups, this one and this one. So I wanted things that I want to have as a connection is maybe these connections. So let's see if it's how this is being set. Okay, so after it's been updated, the DNA, yeah. Inside loop, there's only one loop, I guess, in this case, so it's easy to analyze. So one of the geometry is like this, and one of the geometry is like this, and if I unpack it, you get a bunch of primitive. I think it's same using without the tick here. So made it back. I'll make this back unticked. Now center and center, making connections, fuse, calculating measures, get the smallest lengths and the smallest edge. Now, okay, so it's connecting between the hallway and the room. But now that I see these two together, it's kind of obvious that the the center of this edge and the center of this edge distance must be the connection candidate, not the center of the room itself. So maybe what I need to fix is this one where I created the center. So instead of getting the center of primitive, first I am going to, I already have the edge information here. Yeah, it's getting dirtier. I think I need to organize this a little bit. I'm going to get the center of these edges instead. Which should create more optimized shortest edge between edge to edge, right? And now let's go back, see if it's gonna fix it, if it's fix the problem. So 1, 2, 3, 4, 4. Nope, still not. 1, 2, 3, 4. So in the fourth loop, I still have some problem here, which is, wait a minute. Why do I still have these two? Doesn't seem like the DNA has been updated previously. Wait a minute. If it's 3, okay, DNA is not being updated for some reasons. Wait, let me check again. So if it's when it is equal to 3 and I'm not taking the single pass, the number of DNAs is 7, but the new one is 6. Okay. AA, BA, BA. If I make it to 4, I still get the same DNA. Huh. Okay, something must be wrong. Okay, I realized that I shouldn't do unpack here, which reset the attribute DNA. So maybe when I do the unpacking, I need to also transfer this new DNA. I think that's what I needed to do. Yeah, I think. Let's see again. So the same for these one. Transfer the DNA. All right, now let's go from 1, 2, 3, 4. Okay, going better. Okay, in the end, I get some weird lines. Which I think is because there's only one single primitive. I mean, pack geometry. Yeah. So if there's only one, then I need to skip it. I could check that by having some conditions here. Set this to attribute if number of primitives is equal to 1, then that's when you want to stop this loop. Stop the, how do I call this? Stop hallway. Okay, and on the next loop, I'm going to create a node to be used to check the conditions. And read the stop condition information from that node. If it's 1, just stop it. Okay, now it works. So I can just set it to 100 or 1000 or any number. But it just stops when the primitive number is equal to 1. So it's gonna be safe. Alright, looks good. I guess it's time to organize, but let's also see if it's been snapped to a grid. The line is always centered to the grid, so that's useful. Yeah, everything is snapped. I think it's fine. Now, need to change some parameters to see if it it's gonna work on any conditions. There could be, okay. Yeah, there could be some conditions like these which fails to connect the lines, so we'll also need to fix that. Okay, let's see those. 2, 3. Okay, first of all, these diagonal, yeah, let's see why this happens. Okay, so what's the candidate? This one and this one. Okay. Fifth one. All right. Now I have this one and this one. Oh, okay. Okay, let's reopen it. Hopefully this is being backed up. Okay, I think I have it. Let's salvage it. Let me open this. The crashes just happens even though I have 128 gig of RAM. It's not supposed to be huge memory consuming system. Okay, where was I? So I wanted to, yeah, check this connection here. Okay, let's look from the top view. Now let's check the resampled one. Oh, okay, I see. So seems like the edge that I took, instead of getting the distance from this line, which looks to me the correct edge for this candidate, instead this has been chosen. That is because I was creating a line between center to center, and that was the reason. Yeah. Yeah, that's the reason. So maybe this is not so efficient after all. Instead of using center to center, probably want to use the center to shortest distance or minimum positions. So to do that, for this one, wait, it's okay to get the center, but for the second input, I probably want to snap it to these curves. So meaning I need to create two connections, not to the center to center, but center to the edge. So for the first one, connect with these polypath, and second one polypath. And I need to update this one to make it as minpos. Same as this one. Which made the option a little simpler. So you have these connections coming from this center to these edges, which you're going to get these shortest lines. For this, again, from the second input to the first edges, you get these connections. And then you could then merge these two together as a candidate. Then choose the smallest one out of all those options. See what happens. And now it becomes straight. Still have some problem here. But let's check that as well. Is it here? Maybe not. Three. Okay, third one. Okay, again the fifth one. So these are the candidates. This is the shape, this one and this one. I see. And okay. So now I got these. And the edge, oh, this is I see. Since this edge is touching the corner, I wanted to get this one, but instead it got this one. And currently I only pick one primitive. That's not really what I want, is it? Do I have two informations here? Oh yeah, I do. Actually, I do. So the first input, I should always get one, hopefully. But for the second input, there is a chance that I get multiple numbers. So let's give a loop. And if primitive, I should just start with 1, and if it's equal to primitive number, then reset it to 0. Okay, that way should be able to keep all those informations. Okay, that'll do. Yeah, 2 primitives. 1 primitive is missing DNA, but I guess it's fine. And after that, should be able to get yeah, optimized line. Now let's see back again. Uncheck the single pass. Go till the end. Now I'm going to test this again by changing some random seed and see if I'm still gonna get any unwanted result, and I do get a unwanted result. Now when does this happen? Okay, in the last loop. I also get diagonal here, which I want to fix that as well, but this seems more problematic. So I have 2. Wait, 2? Seems like I only have 1. 1 and just edge. How come? That's weird. Where does this come from? Let's see, 8. I had 3, 1. This edge is being isolated somehow, so probably this edge is creating the problem. Now it's been created like here. Single pass. Okay, this one. Let's check again. So this is a candidate between these lines and these lines. Right. And one of the reasons it's been isolated is because DNA hasn't been transferred. So let's see. When I created the line, I am passing the DNA from the primitive wrangle, which is not currently available. That was the reason. Where did it disappear? After doing the convert line. Okay, so let's transfer that information. Okay, this should have transferred all the DNA and len DNA. Do the same for this one. Okay, let's see. I still might need to fix the diagonal curve like this one, but it should fix the isolation at least. Okay, so isolation is gone, but I still have this diagonal curve problem. It's not a big problem, but I want to fix it as much as possible. I mean, there is a chance that you could use no straight line based on this position of the grid, but as much as possible I want to make it straight, and I think in this condition it should be able to make it straight. Okay, so in this case, it's a connection between, I see, vertical and horizontal. And that's what I don't want. Checking the original curve. These one and these one. So maybe I could give another conditions. Once I chosen the edge, the connection must be in the same direction. The edge direction must be in the same direction as the other one. That could be another conditions, but where should I set that info? So in this case, I have this candidate and this candidate. And that is because I have these original one intersected with this one, but okay. I need to use the same code for this one. Okay, now it becomes straight. Okay, one by one, deleting all those bugs or unnecessary process. Okay, getting better, I think. Let's see again. Changing the seed. Hopefully I don't get much. Okay, at some point I did see diagonal. There you go. I think the reason why it's because there's no straight connections here. So in this case, I think I'll leave it like this. And yeah, just replace with the diagonal grid. Or you could, for those diagonal curve, I could use like shortest distance curve to create a turned curve within the grid. Now overall it looks good, so it's time I can replace the curve with the actual grid, also with the room as well. Shall we? So since I'm going to reuse this grid, I'm gonna name it base grid and use object merge to jump, get the info from this one from far away. Okay. So I'm gonna make a copy of this, and after I get the final rooms and curve hallways, it's time I fit these info to this base grid. Okay, so connect it with a primitive wrangle. How do I now I'll just calculate the distance, smallest distance. And if the distance is smaller than the resolutions, half size of the resolutions, it must be touched with the room or hallway, hopefully. The resolution size is this one. Then let's see, let's try to color it first. Okay, well, not so good. Wait a minute. Maybe a distance must be smaller. 2.5. Yeah. Yeah, maybe that's better. Okay, and well, I do have some problem here with the diagonal line, so maybe I need to fix that first. Other than that, looks good. Yeah. I mean, if you want to change the color, if it's hallway, then you can have another conditions by adding primitive number informations as well as UV. Also, before doing anything, let's unpack everything to get the group informations. Also, transferring DNA. Uncheck it. Now, if imprim group 1 hallway for this primitive that's being touched is equal to 1, then make it red, else make it blue. There you go. Now that's pretty simple, but what I wanted to fix is these one. So let's fix that. I could do this after creating all the hallway lines, or I could do this within this loop. But in order to, yeah, maybe I should do it right here. So once I created the diagonal line, supposed to be a diagonal line, I want to align this into a grid. But one problem is that if you look at the straight lines, straight hallways, it's on the center of the cell. It's going through the center of these cells. So I think I need, in order to use the shortest path algorithm, you need to fix the grid itself so that you could go through the center of these cells to find the shortest path. So what I would do, maybe I'll just do this outside the loop because this is already too dirty, too complex here. I'll do this as a final touch. So to do that, first of all, it's better you split the hallway with the room. Just get the hallway, and what I want to I want to apply the shortest path algorithm just to those diagonal curve. Okay, so you first need to determine whether it's diagonal or straight, perpendicular to 90 degrees to X and Z axis. So give some conditions here. It's pretty easy. You just need to get those 2-point information. Then get the direction between those 2 points. And calculate the dot product or cross product which one should I use? I'll calculate the dot product. So dot product between direction and, let's say, x-axis. So if it's aligned to x-axis, then you get either -1 or 1. If it's perpendicular to x-axis, you get 0. So if neither of these values, then it's diagonal. So if absolute value of d is smaller than 0.99 or larger than 0.01, then it's diagonal. I think. Let's check. Diagonal. Nope, didn't work. Yeah, no, seems like everything is 1. Maybe the condition that I set is wrong. Let's check the dot product that I got here. So d is either 1 or 0. Okay, let's check the absolute value. And I think this is the diagonal one that I want to retrieve. Other than that, I want to remove it. So, oh wait, this has to be an and that should do it. Let's make sure. Okay, so now I get the diagonal curve. This is where I want to use a shortest path algorithm. It's better to have small number of curves for shortest path because that's pretty expensive algorithm. And I just gonna use the node provided by Houdini. Okay, so first thing first, I need a base grid. And since this curve is not on the grid, I'm going to modify this grid by using divide node. Calculate the dihedral, dual. And forget about the max edges and convex polygon. And that will shift the edge to like this, creating new polygon using the center of the neighbor squares. And this could be used as a path for the shortest path. Now, still the point is not on the grid, so let's snap it. Which I can copy one of the code here. Right, then do the shortest path. find shortest path. Now there is a chance that you get multiple number of lines, so let's set this to for each start to corresponding end. Connect the grid to here and set the start point group to start, end point to end. Now I need to set the point group for this grid, which one is touching with these start point and end point. Okay. By looking at each let's see, is this the efficient way? I'm gonna go like this. After being snapped, I'm going to get the closest point number for this grid, and apply that number to the attribute called npt. Now I can connect it here, here, and then search for the point which shares the same attribute. Find attriv val from second input, npt, point npt using the current point number, okay, which should gives you one informations. And now you also want to get the primitive number from this point. So point prims pt, and just get the first one. Now it's time to apply an attribute set. If pt is more than 0, more equal than 0, then that means you were able to find the points. Set point group. I need to know if this is the starting point or end point. Get another list, and get the index for this pt. If this is 0, then that's the first point. If this is equal to 1, then that's the end point. Okay. So if it's start, then that's in 1 minus index. If it's end, that's just index. Okay, and let's also check the color. Okay, hopefully you have one start and one end. All right. Now that you have a set, and let's also apply an attribute point for the connection number, which is this prim number itself, which is going to be used to sort the point for the give the corresponding start and end. Alright, and that's pretty much it, I guess. For the other points, actually, why did I do like this? For the other point, I can give just -1 as a primitive. Okay. Now, give sort for the points by attribute using prim. And finally, you can connect these two lines. Okay. And let's also turn on consider turning cost to avoid too many turns. Alright, now that I have these curve, let's merge these with other straight ones and connect it here. See what happens. Yeah, I forgot to merge this one as well. And I think I need to set the group called hallway to this one. Seems like it's intersecting with the room. I don't like it. So let's fix that, shall we? Well, if room is always more affects more the weight of the room, or the room, if the room could cover the hallway, then that's no problem. So since I'm using hallway group to check instead, maybe I could use a room group instead. Nope, didn't solve. So, okay. The reason is because of this XYZ distance. Yeah. So if it just touches with this one, the hallway curve, then you don't really, these conditions doesn't really matter. So I think I need to trim this curve by the room. Trim these part. Now I forgot if there are any no to trim it. Is it stitch intersection? Does this solve? Input triangle mesh. Let's see. Nope. Well, it's been splitted, but I don't really want these mesh inputs. What else? Curve intersect. Maybe not. Okay. I'll just let's check the grid. Okay. Okay, and let's check the path here. I mean, this is also not touching the grid, but this is fine because it's going to be covered by the cell. But this is the problem here. Right. Now, well, maybe I'll just stitch it after all. Hopefully I'll be able to get these group being preserved after being stitched, and just get the hallway group. Nope, didn't work. What kind of information do I get? There's only one hallway. Why it didn't work? The point is being retrieved. Okay. Fine. Then let's check the intrinsics and check the closed. So the one that's curved is not closed. The rooms are all closed. Maybe not. What are these two? Or do I have any info which shows the type? Poly, there, everything is poly. Nope. Type ID, nope. Well, I am going to let's see if I can use this closed intrinsic. Let's see if I can get the open curve. I'm not sure about these two values, but let's try. Primitive. Prim intrinsic 0 closed. If this is equal to 1, then delete it. Which is the same as the original. But at least it's been splitted. Yeah, so split it into 2, but I have 3. Anyway, that's not a big problem. I just need to remove this one, this part here. But now that I think of, should I just delete the points which is inside the mesh, inside the room? Maybe that's easier. So I'll do that. I'll check with the room, check the distance. If it's small enough to 0, equal to 0, then just remove that point. Yeah, just that will just do it. Okay. Took longer than I thought. Let's see. First thing first, I need to check if this is going to work with different parameters. So going back, seed, change the seed, still works. Okay. Changing the resolutions, still works. Okay. Minimum edge lengths still works. This still works. Okay, everything seems to work pretty well. All right. So this is pretty much a base implementation of the basic BSP, so-called BSP. And additionally, I could add like few connections between rooms as a optional connections. Since there, to me, it seems like there's a bit few connection, even though all the rooms is connected by some. I might want to have like connections in between some of those rooms as addition. So maybe I could have that. So let's see how I could achieve that. But before doing that, let me organize this a little bit and see if I have promoted all the parameters that I could change. So this is the base, and this was creating a grid, the initial grid, snapping. And if I'm using the same code, then I want to make the code synced together, which happens somewhere around here. Okay. So I have pick A and pick B. So this is using different code, so that's fine as is. Now this is pretty hard to read. Let's make it Alps longer. Organize this a little bit. So this one and this one shares the same code, so I'm just going to Control Alt Shift and copy it. Okay, so that shares the same attributes. This one and this one also shares the same code, so do the same. Copy. All right. Now I have so many far off connections, so let's connect together this with a group or network box. Now this is getting dirtier. Wait a minute. Am I missing some connections here? This needs to come here. Okay. Let's have object merge, since this is a bit too much network. This comes from attribute transfer. I'm gonna connect this one. What was it for? It's a B lines. Just gonna call it like that. And I'm going to call that with object merge. Connect it here. Okay, and this one is being used in different places as well. So, okay, same for these. This is A lines. Replace it with A. Connect it here. Connect it here. All right. These code are also the same, so let's synchronize it. Okay. This is not necessary. This is creating a line in the end. And I have this input and end, which I think is a good idea to have again a null node. I'm gonna say hallway start and hallway loop start, hallway loop info. Now, I'm gonna use a object merge to look into this so that I can avoid a really long connection, as well as these one. Okay. Clean this up. Okay. Getting there. What's this? So we'll just bring it here so that it covers the place where it's using. Okay, so that's the hallway. Which took really long node to achieve that. Why am I connecting this one to the for each? I think this is not correct. Is it? Why do I... Wait a minute. I think I'm misconnected, but it still work. Why am I having this connection here? How does this being used? I forgot. So this is the original geometry, right? Which should come from... Wait a minute. I don't think this needs to be... but it changes. That's... just changes the randomness, I guess. It still work. I don't really... Why the heck? So this is the feedback loop, and in each feedback loop I'm getting these informations, and it's using... So it's not really using this information. This is always empty, isn't it? So why am I connecting it here? To get the iteration. Okay, so this doesn't need to be here, but it needs to be connected here. Whole way. This is a Okay. Yeah. That'll do it. All right. So, getting the hallway. Merging these every info together. Right. Okay. I think that's that. Not really clean yet, but at least a bit more readable. All right. Now let's get to the adding additional hallway. So I could do, after having all these being calculated as a basic stuff, and I think I can add additional curve with this diagonal check one. I mean, after being split it between curve and the hallway curve and the rooms, I could add additional hallway to this node. Okay, so in order to create these, I still need the room informations. In this case, maybe additional one could be somehow diagonal, maybe. Now, how would I make it? Let's see. Well, it could be randomish, and so I'll just create a lines and randomly connect points between edges, and then just pick one of those, a few of those, to be an optional connection. Okay, let's do that. First thing first, I am going to scatter some points on top of these curves. Just a few, and then project this. Hopefully I can, for example, like for this curve, I want to project it to a neighbor rooms and so on. Okay. Now, how would I do that? How would I do that? Well, I'm also going to use the room info itself as well. Now for the rooms, let's connect this room to a null node called rooms. And again, using object merge to link to it. Okay, now I kind of want to offset the points a little bit outside, and also give some normal direction so that it goes out of the room. So I will extrude the rooms a little bit, just a little bit, without front, and calculate the normal. Also, let's make this unique. Calculate the point normal and project the normal to the point. By using maybe array node, using minimum distance and in point intersection normal, and see. Okay, now now that I have these informations, I could then calculate or create a straight line and search for the intersections with other curve. Okay, so I could calculate intersection between these convert line, I think. Intersect at P, this is the starting point, plus a little bit of offset, and normal distance with pretty far away, and I think maybe it's better with the extruded geometry instead of curve. And if that's so, maybe it's better if I transform this to y minus 0.5, since the height of this extrusion is 1. So it should always have some intersections with curve and mesh. Okay. Now, if inter is equal or more than 0, then there's an intersection. You could try creating a new line, a new point. New line between the current point number and inter position. Okay. Now these lines looks pretty long. I'm not sure why. Let's check. Okay, so it does. Okay, it makes sense. Yeah. So it doesn't go through the rooms. It just go from one room to another. Sometimes it's pretty big. Sometimes it's pretty short. Okay. Now as a candidate, I think this is fine. Now, what? And let's clean this up so that I don't need unnecessary points, unused points. Now I also want to delete some of the curve which is touching, which is close to the curve that I already got from the Basic BSP. So let's get that as an information. And let's check if the distance is really close to each other. Now, how would I do that? I'm going to resample this edge. Oh, before doing this, maybe it's better if I snap it to the grid. Right? In which timing I should do that? Maybe for these scattered point, I should snap it to the grid. Okay, so going back to where I created the snap. Okay, let's copy this. I also need a base grid. So let's snap these point that I created with the scatter node to the grid. Okay. Now you have more clean lines. Okay, cleaner lines. All right, now let's also make sure I don't have duplicate lines, just in case. Okay, now it's time to check the closeness. Now what I'm gonna do the same thing I did here, resample, using the resample with the size of the grid, which should be, yeah, it's on the grid. Then use point wrangle to search for the shortest distance to the hallway curve. And if the shortest distance is too small, then just delete the original, the primitive that belongs with these points. Float the xyz distance to the current point. If distance is small enough, then get the primitive number from the points. Then remove that primitive. Okay. So it is deleting based on the distance between the curve. I guess these values should be related to resolutions as well. So going back to the resolution, paste it and multiply by some distance that you want to make it far away. 5. I don't know what's the best value for that. Well, let's see, 5. Maybe parameterizing it is better. Okay, now I could try merging it with the original curves. Still need to make a hallway group to this one. And see what happens. Nothing happened. Okay. The reason is because I shouldn't snap to the base grid, but I had to snap it to the dual mesh of this grid, just like other curve. Okay, now what would happen? Okay, did it? Okay, so new points has been added. Now for the number of connections, you can control it by going into a scatter, change. Ooh, that's not good. I think you have to look for the neighbor hallway. I mean, yourself. Currently, so it was checking with the original hallway, but you also have to check with other neighbors, the same kinds of your kinds of curve, in the same geometry node. Okay, yeah, makes sense. So let's see. I could still use XYZ distance, but I think it's going to be a bit heavy because I have to set the group for the searching to search without using the current, your own primitive number. In this case, for this XYZ distance. Right. I'll copy this. And for this this one you're looking into yourself, but with some group info. So group info could come to the second input. Okay, now you need your own primitive number, and you need to say that you want to search where the primitive number is not yourself. Oh, it's faster than I thought. Okay, in this case, you could change the threshold to something like 3, maybe. I think even if it's 2, you could recursively run this. Doesn't really much change it. So I guess these numbers are more important. 4 looks good. Maybe I don't need a for each loop for this. Okay, now gives you a better result. Okay, so additional number of points. Okay, too much points. And if I control these reducing number here, like if I set it to 2, it should be having more points. There's a chance that I get more points. It's too close. Maybe 3 could be minimum. It's pretty hard. Still looks pretty close, but yeah, at least if you could control the number of points, then I guess that's fine. Okay, I guess that's it. This is additional points. Let's have those parameters applied, promoted. So one is point number, additional maximum additional hallway. Could be from, I don't know, 1 to 1,000. Doesn't go that much, but... And this one is... This can be parameterized. This is an integer value. Distance from additional hallway, this one, since I have 2 distance. Let's duplicate it. And for each of them, let's set the range from 2 to 10. Okay, now copy this parameter, Paste it right here. Copy this parameter. Paste it right here. Okay. Alright. Not so important, but at least you could add additional one. Okay, that's pretty much it, I think. Now it's up for, I don't know, visualizations, I guess. For each, I'm using primitive wrangle and set the hallway, set the room, and for the other conditions, set the void. Now you could delete just the void part. Why I'm not getting everything here? Oh, this has to be. Wait a minute. Why is it? Set prim group in prim group. Oh, okay, so I have to do like that. Okay, finally. Now I could set the color for a hallway as well as room separately. Currently it's primitive. And after this you can just do whatever you want with these informations. Okay, that's it. Took a bit of time just creating the simple algorithm, but at least it worked. Alright, I think this is it. If anybody's still here, let me know if you guys have any questions. If not, I'll end this live here. And thanks for joining and all the comments. Sorry that today I'm having a bit of warm color display. Not sure why. Gotta fix that. Well, let's try out additional. Changing the parameters to see what happens. Okay, so I can change the seed. I can change the resolutions, change the minimum edge lengths. Also, I could increase this a split num range. Let's say maximum is 100. Now this is a lot of edges, a lot of rooms. It's more like it. Okay, I think it's working just like I want it. So thanks for joining, if you're still here. I'll upload the files to a Patreon so that you can go to a page to download it and watch the archive as always. After finishing this live, I'll upload it. Okay. Other than that, I guess there's no questions, so I'll finish this live. Thank you for joining, and hopefully you'll found it interesting. At least I like it. I like it. Yeah, solved many errors, so it's pretty versatile. Okay. Hopefully you could use the setup, or you could use some algorithm in some way in your own project. Seems like sort is taking a lot of time to calculate. Didn't realize this cost that high. What did I use this for? Perimeter. Okay. Well, I don't know any other way to sort out, so this is I guess I cannot go with this one, so I'm just gonna leave it. Okay, thank you very much for joining. I'll hopefully see you next week as well. Hey, good night, and see you. How do I? Okay. Where is the